Okay, so that means the location has been created. You can go to the properties and you can see the details. See, these are all the details. So here if you see here, Scott got under this one we have the DB connectors and all DB connectors directories. So the DB connectors is nothing but, let us say in the same database, suppose Scott want to connect to some other schema, maybe HR or some other schema, then internally it will create a DB connection. So that you don't need to worry about it, internally it will take care. So for the time being we have created the location. New location is Scott. Okay, so I will use this Scott location for my module. So I'm coming back to the module. I'm trying to create a new module here. Under this one I'm giving the same name, Scott. Okay, so here you can give the description. Scott user is Scott user will be used as source. Okay, you can give some description there. So I'm going there. See, we have the already we have defined the location, right? So it is coming here. So otherwise by default Scott underscore location it is saying. Maybe what you can do is, you can, if you want, you can use the existing one, but if you are using this one you have to provide the details, because that is the default notation OWB is using. So for the understanding purpose, let us do one thing. Let us go to the Scott and rename it to Scott location or something, Scott underscore location. Okay, we are also using the same name, Scott underscore location. I am using this Scott here again. See, again it is saying that Scott underscore location, because the first one is, it comes default. When you are choosing the default one, you have to define the values. So instead of that, what I am doing is, I have created my connection, I have created my location, and I have verified, and that is working. Now I can use the same location. So if I see, after selecting this Scott underscore location, all the values are populated here. That means these are all the parameters you have already defined and you are going to use them. Okay, so next I am giving module definition is completed. When you click finish, the wizard will create the objects with the following settings. See, these are the options we are creating. Finish. See, under this one again we have a different options. Mappings, we have transformations, all the different kind of objects are coming. So by default nothing will be there. We will go one by one into the details. Okay, so okay, now we have created the module connection. That means we have created the connection to the schema. Okay, now we have to define the metadata for the different kind of objects. Okay, we have defined the Scott user, okay, with the password, database details, and we are able to connect, but we do not know what are all the objects available under Scott user and what are all the objects that we want to use. Okay, that means, let us say I have employee table, department table, and all those things in the Scott user, but right now if I'm going to the tables, and if I see there is nothing visible, because this is the place where we are creating the Oracle Warehouse Builder metadata. This is not the actual Oracle database objects, right? So if you go to the database and if you verify the different tables under Scott user, then you may find all the details. But here for the first time, when we in the beginning, we will not get all those objects by default. You have to create the metadata for different objects. What are because under the SCOT schema, there may be n number of tables, there may be hundreds of tables, and for your project purpose you may not be using all of them. Maybe 1 or 2 tables or 10 tables, let us say, you want to use. Okay, in that case you have to define all those structures here, so that Oracle Warehouse Builder can use them when you are building the ETL part or programming. So let us see what are all the objects we have under the module first. Okay, under the modules we have the mappings, transformations, data auditors, dimensions, cubes, tables, external tables, views, materialized views, sequences, user defined types, queues also we have. So let us see what are all these things one by one. So mappings we will come to the we will see at the end, because that is the last point. So the first point for any module is a table. So table is nothing but the database object where we can have the different columns, and we can have a number of rows or data in that particular table. Okay, and the next one is views. View is nothing but it is a window for a particular tables or a combination of tables. Okay, so that means let us say I have one table. Let us say I do not want to show all the columns for the users. So then what we can do is I can create a view with the required columns. Okay, and I can give access on this view to the required users, so that instead of getting the access to all the columns, they will get access to only the required columns. This is the security purpose. And also in sometimes what happens is in the table, let us say there are n number of columns, maybe hundreds of columns or 50-60 columns, and for my project purpose, for my ETL or programming purpose, I do not want to include all of them. I need only 4 or 5 columns, let us say. In that case I will select only those 5 or 6 required columns, and I will create a view. I no need to bother about all other things. Okay, so that is nothing but a view. And similarly, not only on a single table, what we can do is we can join different kind of tables, and you can create a view with the required columns. Okay, for example, I will show one example here. View, let us say we have select a star from EMP table, right? So in this table I have a number of columns. I have 10 columns. I don't want to see all the things. I just want to see only the employee name. Okay, employee name only I want to see, right? So I can create a view with this definition, create a view as a select star from with employee. That means when I am accessing this particular view, I will get only employee name. I will not get all other details. Okay, and similarly I can join the employee table with some other tables, like let us say I have department table D, where I want to get the department name. No, I don't want to have the department number. So let us say what I can do is where e dot department number is equal to d dot department number. So what it will do, I will get the employee name from the e table, then I will get the d dot department name, and I will create a view. Let us say I am create a view employee EMP as like this. So using this one I will get employee name, department name, and you can include some other columns also. Okay, these are the simple simple queries for a views, but there can be complex things. I may be doing aggregations, I may be using, let us say I want to find out the department, for each department how many employees are there, for each what are the top 10 maximum salaried employees, okay, and what are the maximum count, what are the departments which are with maximum count, what are the departments with the maximum salary. All these kind of queries actually you can build here and you can create as a views as per the requirement. Okay, that is the thing. So there can be here two tables I am joining here, but a number of tables as per the requirement you may be joining them. Okay, so every time you know you don't want to create the joins and all, and you directly want to use the definition that is created for the view. That means joining the 5-6 tables with 5-6 conditions, and finally let us say you want to use them, then we will create a view and you can use them. So that is about view. And the next one is external tables. External tables. External tables are similar to tables, okay, but the difference is that let us say I have a file in the sense I have a flat file or a CSV file or Excel file, okay, and in that file I have the complete data. For example, let us say I have all the employee details, okay. So I have from let us say I have employee name, okay, employee ID, I have the department name I have, okay, and I have the employee salary and when this particular employee has joined in the company. Let us say these are all the columns, okay. For all these things I have prepared one flat file. This flat file can be fixed length, okay, or comma separated, or Excel file, or CSV file. Comma separated is CSV file, or tab separated files, okay. So in that file I have created the data and I want to read the data from this particular file. This file may be something like, let us say the first column I have said employee name, and next one is employee number, and next one is a department name, okay, and the next one is salary we have, and then let us say we have the date of joining, hire date. These are the columns let us say we have in a particular flat file. Let us say I have a flat file with the fixed length in the sense employee name I am fixing for 10 characters, okay, XYZ, employee name is XYZ, okay, that is for the first 10 characters. And then comes the employee number. Let us say I have 4 digits, okay, I have 4 digits. And then I have the department name. Let us say this department name is also fixed length with 20 characters, okay. Let us say this is the department name. And then again let us say we have the salary. We have generally it will be number, but I will have a fixed length with 5 digits, okay, there are no decimals. Let us say 5 digits, this is the fixed length, okay. And then I have the hire date. Generally we will have date, month, year format, right? So this fixed length what I will do is I will have DD YYY, okay, like this. I have defined one flat file. So similar, this is the first row, okay, This is the first row, and the second row also something like this. Okay, and the third row is also something like this, second row, and again something like this. So that means here I have two rows in my particular flat file. So here the flat file type is fixed length. So what we can do is, see, I'm opening the flat file, I'm saying okay, I'm calculating, I'm doing okay, then that is fine, I can understand. But when it is coming to the database, how this flat file can be read by the database so that it can be used in the project, let us assume. Then what we have options is, we have options in Oracle that external tables we can use to read the flat files, not only flat files, any kind of files. Here for example, I am taking here a flat file with the fixed length. Okay, so here I will define a external table with this file type, saying that for each field this is the fixed length, and this is the file name, this is under this particular location, so please read the data. So the external table, when we are configuring, what it will do is, after creating the definition, it will go and fetch all the data and it will display in the table format. Okay, so external table is similar to table, but only the difference is it can read the data from files with the given definition. Here we have seen a fixed length columns, and similarly we can have columns something like comma separated. See, employee name completed, so after that I am giving a comma or semicolon. Let us say we have semicolon, separated column file, semicolon again, semicolon again, and at the end we have the colon like this. So for the second row also it will come, but here it may not be required that it should have the same length. In the earlier case, if it is a fixed length file, employee name, for example, employee number 1, it has 10 characters, but employee 2, let us say 20 characters. In that case, when we are preparing the flat file, what it will do is, the extra spaces it will leave. You have to trim when you are using into your database. But when you are using the semicolon separated or comma separated files, you don't need to do that. Just it will take whatever the length you are giving, but you have to make sure that the separation is done properly. Semicolon I am again giving here also something like this. Let us say this employee has only 3-digit salary, and again this DDMMYY format. See, here I am not giving the this is for understanding purpose, this is the notation I am giving. So here NN means, okay, you can give some number, it can have some, let us say 3000 something like that. And the third one is department, right? Let us say I have finance, and employee number is, let us say 400, and the date is, joining date is 01/01/2016, okay, something like that. And employee name is also here, you will see some name, maybe you can give some name, something like that. Okay, this is the how the data will be represented in the files. So this data will be read by external tables. So if you are creating the external tables directly, the advantage with the external table is it will read the data from the files. That's the first point. You can modify the file name any number of times by altering the table, external table definition. That means this file name is let us say file 1 dot CSV, and tomorrow let us say I got a file 2, but with the similar structure, similar notation. Then what I can do is I can go to the external table definition again, and I can modify the file name to file2.csv, and it will read from the new file. So these are all the advantages we have with the external tables. And similarly, what we can do is similarly we can, these external tables we can use for joining other tables also. That is also advantage. Okay, so in Oracle Warehouse Builder we have the option for external tables. You can use them. Okay, and again materialized views. Views and materialized views, they are similar. Let us say I'm saying them as materialized view as MV. What happens when a particular view is created? Let us say I have created one view and I want to access that particular view. When I'm trying to access that view, select a star from view 1. Let us say I'm doing that. At that time, the query behind that particular view will be executed and it will populate the data. It will give the data to the requested user. So here what is happening is the query is running when you are requesting the view. For example, there are 5-6 tables joined together, and if you are trying to see the data, then it may take some time, because the joins it has to perform and it has to do whatever the aggregations or rankings you have given, all the things it has to perform, so it will take time. So that is also let us say it is I do not want to wait for such a long time, because let us say this query is taking 5-6 minutes. I do not want to wait, but the data is coming maybe in the morning time. So what we can do is we can define a materialized view, and we can refresh the materialized view when the source table data is available. Okay, so what it will do, what is the materialized view it will do is it will materialize the complete definition, and it will prepare the data as per your definition. Okay, so how it will do is, you have the options in the materialized view definition. When the commit is happening, rollback is happening, or you can refresh the materialized views manually. That means, let us say the source tables, that data is available. So I decided that there will not be change for the next one day. What I can do is I can go and refresh my materialized view. Okay, then the data, if anybody is querying this particular materialized view, then the data will be very fast. The query behind the materialized view will not be executed at that time, but it will be executed during the refresh time, and it will prepare the data readily and you will be using. Okay, that is the basic difference and advantage with materialized view, but there are a lot of other advantages with materialized view. Okay, for the time being we can say that these are all the different things we have. So materialized view also you can use if you have defined something in your database. You can use them here. And then the next object is sequences. So sequence is very important for a particular data warehouses, very widely used object in data warehouses. So sequence is, as the name is indicating, sequence, it will generate the numbers in sequence, and you can use readily in your applications. For example, let us say I have a primary key and I want to have the sequence numbers. For example, I have an employee table. Okay, under the employees table, let us say I have a employee ID. Okay, so this employee ID should be unique number. Okay, and it should be incremented when the new employee is created. For example, employee, under the employee ID, and let us say employee name. Okay, so the employee name will be 1 and the first employee is this one, and second one is this one, and next one should be the next value, right? Here the maximum value is 2, so the next value is 2 plus 1 3, and this is the new name for this employee. Like that, this is the incrementing one by one, and it is in the sequence number. So for the new employees, we have to add the new employee ID, and that also we have to add the next value for the maximum existing employee IDs. So this one, when you are doing with the program, actually what will happen is you have to check the maximum value, and you have to add some calculation for that, and you have to use it in your programming when you are inserting the data. So Oracle, what it has done is it has come up with a inbuilt option as nothing but the sequence, where you can readily use the values. You no need to do all these calculations and all. Okay, so you define your sequence with the structure, like I want to start from 1, and I want to increment by 1, and the maximum value is some lakhs or 9 digits or 12 digits number, something like that. We can define the sequence, and whenever every time when you are querying this sequence for next value, what it will do is it will check the previous value internally, and it will give. You no need to worry about it, right?